In this video, we will try to solve a problem on utility maximization. The question is like this. The utility function of a consumer is given by this very utility function. U is equal to x1 into x2 square minus 10x1, where x1 and x2 are the two goods and U denotes the utility. Find the optimal values of x1 and x2 when consumer's income is $116 and price of good x1 and x2 are respectively $2 and $8. Okay, so we are being given a utility function, income of the consumer and the price of the goods. We want to find out the optimal levels of bundles that our consumer will buy. Okay, so what we are being given, we have utility function. That means we want to maximize our utility function is given by x1 into x2 square minus 10 x1. We want to maximize this utility function, and what we are being given here also, we are being given that income of the consumer is 116, price of good x is price of good x1. Okay, so let me write p1 denotes the price of good x1 is being $2, so let me write it here, and price of x2 is $8. Okay, now what will be then our budget constraint? Simply our budget constraint will look like this. P1 x1 plus P2 x2 should be equal to m. Okay, so P1 is the price of good x1. X1 denotes the units of x1 they're being consumed, plus price of x2, and units of x2 consumed should be equal to m. That means our budget should get exhausted. Okay, so what are the values of p1 and x1? So we have 2 x1 plus 8 x2 should be equal to 116. Okay, so this is our budget constraint. So this is our budget constraint. Now to get the optimal values, we need to find out the tangency condition. Okay, so what is meant by tangency condition? Let's try to figure this out first. So we have, let us say x1 is on this axis, x2 is on this axis. We have budget line. Let's draw a budget line. This is our budget line, and we have this indifference curve. Okay, it will look like this. Okay, tangency condition tells us that what we call that the marginal rate of substitution between two goods should be equal to the ratio of the two prices. Okay, px p1 upon p2. Okay, at the point of tangency, what we mean that our marginal rate of substitution should be equal to the ratio of the prices. Okay, this point denotes our optimal point. Okay, and by marginal rate of substitution, what we mean? We mean marginal utility of good x, x1 upon marginal utility of good x2 should be equal to the price of x1, that is p1 upon p2. Okay, this is our tangency condition, and we also say that slope of the budget line should be equal to the slope of the indifference curve at the point of tangency. Okay, so let me write it here. So our tangency condition is marginal rate of substitution between two goods x1 and x2. Let me rub this out and write it simply. Should be equal to price ratio of their prices. Okay, marginal rate of substitution simply means marginal utility of x1 upon marginal utility of x2 should be equal to the ratio of their prices. Okay, sorry, what is the marginal utility of x1? So this is our utility function. Marginal utility of x1 means we need to differentiate. That means du upon dx1 upon du upon dx2. Okay, so marginal utility of x1 means taking partial derivative of utility function with respect to x1, and marginal utility of good x2 means taking partial derivative of utility function with respect to x2, okay, should be equal to the ratio of their prices p1 upon p2, okay. Now du upon dx1 means taking the derivative partially with respect to x1, okay. So derivative of x1 is 1. Here we are left with x2 square, okay, minus derivative of x1 is 1, so we are left with 10. This is du upon dx1. Now du upon dx2 means taking partial derivative of this utility function with respect to x2, okay. So we have x2 square x2 square, its derivative is simply this 2 becomes coefficient, so we have 2x2 and this exponent is subtracted by 1, so we have 2x2, okay. So we get here 2, we have x1 as it is, and the derivative of this will be x2, okay. And obviously we don't have any x2 involved in the second term, its derivative with respect to x2 will be 0, okay. It should be equal to the ratio of their prices p1 upon p2. P1 is 2, p2 is 8, okay. So we can also write it like this, 1 upon 4. Now just cross multiply here, so we have 4 x2 square, so multiplying these, then we have 4 tens are 40, should be equal to twice x1 x2, okay. Now solving for x1, so if we solve for x1, that means we have 4 x2 square minus 40, okay, divided by 2x2, okay. If we transport this will get divided 2x2. If we further solve this, will come out way, if we take 2 common here, so we are left with 2x2 square minus 20 divided by 2x2, okay. So 2 and 2 will get cancelled, which means x1 is equal to 2x2 square minus 20 upon x2, okay. So let's put the value of x1 is equal to this thing in the budget constraint, okay. Let's put the value here, okay. We just need to plug the value of x1 in the budget constraint to get the value of x2, okay. So just plug x1 is equal to this in the budget constraint. That means we have 2 here, then we have x1. In place of x1 I can write this very stuff, so we have 2x2 square minus 20 upon x2 plus 8 x2 is equal to 116, okay. Sorry, now doing some basic math stuff here. So 2 2s are 4 x2 square minus 2 into 20 is 40 upon x2 plus 8 x2 is equal to 116, okay. Now everything done, so let's do another cross multiplication here. So we will have here uh, let me rub this out. I hope I should rub this out to make the space for the question here. So 4x2 square, 4x2 square minus 40, this is 8x2 square plus 8x2 square divided by x2 is equal to 116, or we can write 4x2 square minus 40 plus 8x2 square is equal to, transposing it will become 116x2. Now transposing this term here, we have 4x2 square, it will get subtracted 116x2, okay. Then we have minus 40 plus 8x2 square is equal to 0. 8x2 square, 4x2 square, they are the same terms, we can add them. So 8 plus 4 is 12x2 square minus 116 x2 minus 40 is equal to 0. Okay, now taking 4 as common, we can factor out 4 here. So if we take 4 common, we are left with 3x2 square minus 4 2s are 8. Now the 4 9s are 36, 4 10s are 40. Now transposing this 4, it will get divided to this 0 and it will become 0. So we are left with 3x2 square minus 29 x2 minus 10 is equal to 0. So we have a quadratic equation with coefficient of x2 square is a, with coefficient of x2 is minus 29, let us write this as b, and coefficient of constant term is minus 10, let us write it as c, and use the quadratic formula. Okay, so x2 will be equal to minus b plus minus b square minus 4ac upon twice a. Okay, just plug the values of a, b, c to get the value of x2. So minus the value of b is 29, so we have minus 29 plus minus, so let me write it here. Okay, so we have the minus of the formula, the value of b is minus 10, sorry, minus 29, minus 29 plus minus, again b is minus 29 square, we have minus, then we have 4 from the formula, a is 3, so let us write here 3, and c is minus 10 divided by 2 times the value of a is 3. Okay, now this will become minus into minus is plus, so we have 29 plus minus. Now 29 square of a negative number is positive, obviously. Okay, so now what is 29 into 29? 9 9s are 81, 9 2s are 18, arda so we have 278, 2 9s are 18, 2 2s are 4, 5, so we have 8 5, I guess it is 841. Okay, I have not done the calculation right. So we have 29 into 29, 29 into 29, Shahmat Gwana. 9 9s are 81, 8 are left, 9 2s are 18. Arda Kunu Akuzdo through 2. So we have 261. Then we have 2 9s are 18, 2 2s are 4, 4 गए 5, so we have 1 और 6 गए 14, 5 गए 7 गए और 841. Okay, so minus 29 square comes out to be 841. Now minus into minus is plus, 4 3s are 12, 10s are 120 upon 2 3s are 6. Solving again, so we have 29 plus minus. Now 841 plus 120, 1 plus 0 is 0, 4 plus 2 is, sorry, 1 plus 0 is 1, 4 2 is 6, 8 1 is 9 upon 6. Okay, so we are just getting the value of x2 here. Now what I need to do, let's rub something to get something. Okay, so what will be the plausible thing to rub here? So let us rub this tangency condition. Okay, so our x2 comes out to be 29. Now what is 961? 961, its under root will be, so we have 3 3s are 9. Okay, 3 3 is 6, 60, we are left with 61. 61 into 1 is 61, so this comes out to be 31. Okay, we have 29 plus minus 31. Okay, so 961 can be written as 31 square. Okay, square root will get cancelled. Then we have 6 here, so we got two values of x2 here is 29 plus 31 upon 6 and 29 minus 31 upon 6. 29 minus 31 comes out to be negative number. We will not use this very number, this very value here. This is the positive one, which will be our choice variable here. So 29 plus 31 is 60 upon 6. We get 60 upon 6 comes out to be 10. That means the optimal value of x2 will be 10. Okay, to get the optimal value of x1, just plug this value in the budget constraint again. So put this x2 is equal to 10, either, sorry, in the budget constraint. So we have 2 x1 plus 8 into the value of x2 is 10, which we calculated, is equal to 116. So we have 2x1 is equal to 116 minus 8 tens are 80. That means 2x1 is equal to now the 36, so which implies x1 is equal to 36 upon 2, which comes out to be 18. Okay, so we got the optimal values of x1 and x2 as 18 and 20, 18 and 10. Okay, that means a consumer will be at equilibrium, or he will be at optimal point when he consumes 18 units of x1 and 10 units of x2, the mm, given the price of x1 is 10 and, sorry, x1 is 2 and x2 is 8. Okay, simple thing. Just use tangency conditions, solve for x1 or x2, put the value again in the budget constraint to get an expression in same variable. Okay, then find the value of x1 and x2. I hope I make myself clear. Thank you.